All right, today's presentation, PH1. I'm really excited for this. I live in North Vancouver. I used to hang out down in this area a lot more. Haven't in a long time. To be honest, I don't think I've been down there to see the construction, so I was kind of disappointed that we couldn't have a live in-person portion of this. But we're going to do it all virtually today, and I know there's some really good videos. So what I'm going to do is I'm going to intro our three speakers. And then let them roll through each one of their presentations. So first off, we have John Hemsworth, principal at Hemsworth Architecture, followed by Andrew Peel, who's the Passive House consultant on this project from Peel Passive House Consulting. And then obviously Joe Galouche, president of Nykun Contracting, will follow that up. So with that, I'm going to stop my screen share and hand it over to John.
So I'll try not to take up too much time because Joe's videos are probably more interesting to everybody of actually seeing this project being built. Our involvement with Passive House started in probably about 2014, maybe a little bit earlier. We were asked to put together some ideas for a factory in Pemberton, which is the BC Passive House factory. There are parts of this that are built to Passive House standard, but generally it's just a big factory, but a lot of our work is based around the use of mass timber and prefabrication. So this is a good example of it. And then there's an office part at the front here and some work areas that were built to Passive House standard. What is interesting about this is, although we finished this building years ago, it is actually one of the suppliers for the exterior wall assemblies on PH1. So you can get an idea, I don't know if you can see the mouse or not, but there's a series of insulated panels that they build here. What's also interesting in the factory is that we're just doing an expansion of this now. So this needs to be updated, the photos. They've blown out this wall in the back and they've built another 18,000 square feet. So they're producing this at a fast and forensic pace at the moment, can't seem to keep up, which is, you know, a nice kind of well, it's a nice development in the sense that where they got their background in BC Passive House, I'm sure you've heard and talked about Matteo before, but was coming out of the Winter Olympics with the Austria House being donated and then being assembled here. And then Matteo and his group got together and said, well, shouldn't we be doing this? So this is where the factory comes from. And it's located in Pemberton, which is quite a beautiful thing. So we can talk about that one. But what was interesting is around the same time, we got a phone call from Christy and Tycho, I believe, are here somewhere in on the call. You can wave, and started talking about kind of doing a commercial Passive House building in the city. So we all know where we are here. We're in North Vancouver. We're right down here at the end of Lonsdale. So the actual site address is 1 Lonsdale in Carey Cates, right in front of the new Polygon Art Gallery. And so this was basically, I mean, the art gallery wasn't built at the time that we started this. There's an existing restaurant, Italian restaurant here, which is going to come back on the ground floor. And so we were very intrigued with the idea of trying to do passive mass timber project in a zero lot line urban environment. I had to write down everything that we were challenged with because we knew it was going to be hard, but I don't think we knew what we were getting into. So it's Passive House certified commercial with a full Italian restaurant in it, meaning it's not induction, they're actually using gas. So there's lots of questions about that with Andrew and working with the Institute to find a kind of a solution for that. It's a challenging urban infill site, zero lot line on the back north wall. We were going to prefab the building right from the beginning. We had to come up with 3 mass timber alternate solutions to get the project through code. One being the ground floor being a assembly space, as the code was at the time, was not, it had to be non-combustible construction. Then the partition of the party wall between the 2 properties, zero lot line, we're going to do it out of mass timber, which Joe will show you some of the miracle of it actually working, because to be honest, as we were going through the design, there wasn't, nobody really knew how to do it. So there was an insulated mass timber wall that had to be prefabbed and dropped in. And then the code was also wanting that wall to be non-combustible construction. So we had to go through that whole process as well. We had to fit within existing zoning because the project had been zoned about 17 or 18 years ago. So we were working within an existing FSR calculation, which we used was less than 3, even though we're going through a 3-story building. We used some allowances that were given in the wall thicknesses to kind of get us there. There is also the flood construction plane level. So the whole site had to be lifted up 8 inches. It's, I believe, the first zero parking development in the North Van, but I could be corrected on that. And then, of course, it all had to be cost effective. So simple, like really quite easy. What you notice here about the existing building is that if you know the area at all, Lonsdale is a series of restaurants running down here at a different scale. And all of them are facing onto Lonsdale. And then Carrie Cates, which is running between the art gallery and the site, is kind of, at the time that the first restaurant was built, was, you know, more of a thoroughfare, whereas now it's becoming this kind of art district. And then the new, there was, you can still see this picture, that there wasn't the new Polygon Tower in the back of it either. So this whole street has been developed, and we wanted to be a part of that, kind of leading the way on this very important corner. So some of the first ideas that came in, and I'll be honest with this, is the clients came to us and started talking about Passive House, and this was years ago, so it was quite progressive in their approach to it. It was never really going to be like just a regular building that happened to see if we could get to passive. There was discussions about mass timber being, you know, very sustainable on every front that we could think of on the project, and kind of keeping within the families, and, you know, Christie's, I think, here on the line, and Tyke, but they have a deep family connection to this site. It's not just something that was bought to kind of flip. It's kind of been in the family for a long time, and we wanted to get something that resonates with their sense of how the city's developed, but also this site and its specifics. And again, we were looking at prefab systems from the beginning. So early on, we were kind of interested about the massing change between what we thought would be the new polygon and how this street became this kind of more important kind of part of the city, being it kind of, instead of it being kind of the low level that it was, it's all going to be kind of built up. So we did some preliminary kind of massings and stuff. And you can see early on that we weren't sure about the height of the building. We were going to try to sneak another floor into it. This whole project was a bias between ambition and the realities of kind of getting it through the city. Passive House is a part of that, as is the mass timber, but they were almost like, I guess, the known knowns or known unknowns, whereas we got into some development kind of like issues, not with the city necessarily, but just inevitably for doing a high profile site like this that you're going to have to deal with. So we were looking at kind of using something similar to the Passive House walls that was developed by BC Passive House, where they're building their walls and basically OSB on the inside, which is taped, blown insulation, and then the Adopan on the outside, with a interior wall on the inside, which has been used for most of their servicing. So the building is then kind of settled into the idea that we didn't want to go into another rezoning. So we were stuck with the just roughly 2.6 FSR, a 93% site coverage, and a maximum height of 11.9 meters. So we kind of then had to fit everything within that. One of the things we were clear about at the beginning was that we knew there would be these peekaboo views and throughout towards the city, depending on where you were in the building. We try to take advantage of that. So this was one of the early iterations of the building, and wasn't very convincing for a lot of reasons. But what we did like about it was the fact that this bottom corner along Carrie Cates and Lonsdale really gets pulled apart and opens up to this new kind of art district within the city. That we weren't looking at just having the building facing Lonsdale anymore. We were trying to wrap it around the corner. So then we started kind of, and this has kind of gone back and forth. One problem with when you have a lot of time to deal with a project is you have a lot of time to change your mind and make decisions and come back and forth. So over the years, like I said, we started this one probably at least 5 years ago. I think, was to look at kind of a palette that we could kind of connect with more, and the client would also feel comfortable with. So we started looking at it kind of using a kind of glazed brick as something kind of heavier and more more grounded, also playing off the kind of lightness and the floating volume of the polygon across the street. So we kind of wanted to do that. We wanted to kind of play off the ideas of an existing warehouse, that kind of like warehouse kind of construction along the waterfront. So we want to expose the glulam and the CLT, and then kind of ground it in this kind of, almost like an existing building, but with a little bit more kind of brains to it as far as its systems, and then a little bit of interpretation architecturally. So what happened here is that we kept the ground floor kind of opening onto Carrie Cates, and then we played out a bunch of series of iterations with the glazing, trying to get an idea that it wasn't going to be super rigid, that there was a kind of playfulness in it, but we were still doing things where we thought that there was a bigger view coming out around the polygon out to the city, that we would kind of emphasize that, and then have the building kind of also having the same but lesser on the side facing the ferry terminal. So there is still work going on with the city as it relates to the edge condition here. Originally, the road was much wider. So now we're looking at bringing the road across, which is helping us with the floodplain. There's going to be restrictions, hopefully, about cars or buses along Carrie Cates, where it becomes more of this pedestrian muse. We set back the entry here. An elevator as you come in to kind of split the occupancies from 2 offices above and the restaurant below, and then just 2 exits kind of dumbbelled on either end, but a very tight site and right up against an existing building, which you'll see in some of the videos. So again, on the ground floor, we have this lobby space, shared entry, the restaurant itself all facing out towards this public space. And then you're not shown here, but the restaurant is actually the kitchen and the bar are back up against the wall. So everything is kind of falling out into Carrie Cates. And then basically just the floors kind of mimicked here above. The 25-foot site width is a challenge on a lot of different fronts, but we tried to kind of look at different options to break these up into individual offices that could be rented, but right now it's probably going to be per floor, just based on trying to get your circulation levels down. And then kind of mimicked on the same floor, on the 3rd floor, no 4th floor anymore, which although it would be a great place for an apartment if you could pull it off. So then what we're looking at here is basically our building sections. So what we've done is insulated slab. What you'll also notice, again, as I mentioned, there's no parking underneath the building, which is a whole story unto itself to get that approved. It's a glulam frame structure with CLT floors and roof, and then all the wall panels on the 3 open sides were coming from the factory in Pemberton. The glazing would have, as all accounts is coming from Austria, I believe, and would have been installed as the panels were going, before the panels were installed, but I believe it's all stuck in a container in a strike in Montreal. And then what is unique about the project, again, is this fascinating back wall. So the wall itself is a CLT that were stacked up against the frame. They were pre-insulated and then clad so that we could kind of slide them in behind the building. They're also working as a seismic, lateral support as well. So it seems simple now that it's built, but it's been a challenge, and full credit to Joe and his team for kind of coming up with a method that worked here, because it's one thing to draw it, it's another thing to build it, as we all know. And then just a kind of screen grab of like, we're basically, besides doing this, are doing our own internal coordination models with the mechanical, electrical, structural, the prefab. And then that's also going now to, we'll then start it with, I think Joe did his own coordination model. And then the big model, I think, started with Structurelam, where they are doing all of their CLTs in glulam. And then all the panels were coming from Dürfeld, BC Passive House, and then the glazing coming from Austria. So the building is really never site measured. It's kind of coming off the digital model, which has been, well, I'll let Joe talk about putting it together. So this is just some quick little ideas from the ground floor here of the insulated slab, again, lifting it up to get it above the floodplain. The beginning of the structure going in here, and I'm not going to steal Joe's thunder too much on this. This is the mystery magical wall that kind of slides in and creates this like necessary fire rating between the buildings, also performs in passive house. And Andrew can talk about all the challenges we had on that front, especially with the ground floor being a restaurant. And then there's the how do you seal these as they're being dropped in behind both a new building that we're building and an existing building in the back. And this was the last panel going up a couple of weeks ago, I think. So start to finish, you can, it's, 8 days, sometimes 9 days of construction from the ground up, but I'm sure Joe can correct me if I'm wrong on that. And that's kind of it. That's our quick story about the project. Like, it's funny to present a project that's not finished for us yet because it's kind of in process, but I appreciate the interest. I'm sure there's going to be lots of questions. Do you want to wait, Chris, and ask the questions later, or as we go, or all together at the end, or?
We're 6:30. What if someone's got a couple of quick questions? There's nothing that came up on the chat, but if anyone wanted to ask a question now for John specifically, if there's something that pops up, going once.
Oh, that's great. I got it perfect.
I do get a quick question. Sorry.
All right.
Was the original prefab looking at the Cree system versus local stuff?
We looked at a whole bunch of different kind of approaches to this of how to do it, because it was kind of, the intent of Passive House was coming from client side from the first time we met them. So we knew we kind of wanted to get to there. The mass timber kind of, approach to where the systems were going to come from was kind of up in the air. We've done a lot of work with Structurlam over the years, including an expansion plan for their own factory. So we're pretty embedded with how they're thinking about things. So they were on early as far as kind of trying to find a kind of a solution, helped us with some takeoffs and stuff early on. But then you could talk to Joe about the actual how we went through a kind of tendering process to find the right fit for it. But it's a small project. See, that's the key. It's small enough that it could kind of be done locally, but also sets a kind of standard of what's possible here. Like I think that having it come from mostly being a British Columbia building, and hopefully we get to that place with the glazing as well, or maybe we are. But this idea of prefabbing it, like a lot of our work now has been prefabbed and mass timber, and kind of pushing it all to an urban passive house kind of project all at the same time was kind of was ambitious for sure. But I'm thrilled with where it is today.
I have a question. You said there were 3 alternative solutions that you had to get, obstacles that you had to overcome there. What and the codes have changed since you put in your original design. Like, would today's code still require those same 3 alternative solutions?
Yes and no. It's a good question. So when we originally did it under the previous code, for whatever reason, on a 3-story building, the ground floor, if it's an assembly space, has to be non-combustible. When we were told the 2018 code, because we had a long view of like a long runway with this, the 2018 code was going to change to make the lower floor that could be combustible construction. So we were like holding off on that we would get to drop that alternate solution. But when it came out, there ended up being enough other kind of like footnote changes in it as far as like a non-combustible roof and all these other things that we would have to do to get it there, that it was actually just easier to stay within the alternate solutions that we had. So that the first one is just a use thing, which I think the new code gets around, but the mass timber like 0 lot line wall, we're doing another one actually. We've got 2 of these twin projects going on at the same time. This one's further ahead, and we're doing another one at Ontario and 5th with Robert Melchuk from Equilibrium, now Katera. And so we're kind of looking at that solution there as well, because there's other zoning issues in the city of Vancouver. For example, they're calling that lower floor an industrial space. And you know that doesn't fit within the building code's interpretation of industrial. The city planning department has considered it an F2, which is kind of a mid risk, I guess, like something like would be the same as like the factory in Pemberton, which means that the city of Vancouver had no appetite for doing that as a non-combustible construction. So we ended up with a concrete lower floor on that project and then the mass timber on top of it. So the crazy part about all this stuff is that it really comes down to literally the head building inspector in the part that you're working with, like in the jurisdiction you're working with, has their own kind of interpretation of what it can and can't do. So Tim Rice on this one was very supportive as we went through the process, but it was difficult for sure.
Okay, I won't spend much time on company background. Just for those who aren't familiar with our company, we're in the passive house space, have been operating in it for quite some time now, 8-9 years. And this is what we do. We're focused on passive house. I think one of the few firms that actually dedicate themselves to passive house, you know, from our consultancy like this on like we've done on Peach One, through building certification training, and we're actually which is a great evolving space is component certification, working with manufacturers that are now that the market's evolving for passive house and we're seeing more and more projects, manufacturers both big and small are actually taking an interest in passive house. So I think that's a great bellwether of things to come. So interesting, speaking about passive house, normally I have way too much to share on a given project. You know, I could speak generally for a couple hours or more on given projects. This one was actually more straightforward from a passive house perspective. We'll get into the commercial kitchen side of things. That's probably the most challenging and interesting aspect. From your passive house envelope perspective, it's from a design perspective, it's actually rather straightforward. I think Joe will be certainly talking much more about the construction challenges and process. So I think there'll be almost more interesting stuff from that end to speak about. But the envelope is straightforward. You know, mass timber. So we've got our CLT wall that John mentioned at the back wall. You know, simple CLT panel with a self-adhered membrane for air tightness and then exterior insulation. We also have the main wall, which is the BC passive house system, so stud-based system. And actually the roof as well, John mentioned it was the CLT panel, so that's got exterior insulation as well. And then also referenced was the floating slab. So we've got a nice near continuous layer of insulation around the building. And yeah, even on the air tightness, mentioned self-adhering membrane both on the wall and the roof. The stud wall had OSB that was taped, standard membrane into the floor. And then the only additional challenge was the elevator shaft vent. So we needed a vent in the elevator shaft. And so we just needed to make sure that that was sealed up with an airtight damper that would activate as required to vent the elevator shaft in where it was needed. Yeah, I mean, that's pretty straightforward. The actual thermal bridging is minimized. I mean, it's basically a continuous blanket of insulation, except for a couple key areas like the CLT parapet, as well as, you know, door thresholds. They tend to be difficult to get thermal bridge free. But really, because of the nice simple box, I mean, this is really a near ideal shape, almost a full box for a passive house. So makes at least the design detailing pretty straightforward. So there's actually not too much to discuss on that. Switching over to the M&E side of things, on the ventilation, so your space ventilation, we do have one HRV per floor located on each floor, right? So you know, one in each office space, and then one down in the restaurant. And I'll talk more about how the restaurant's ventilated. One thing that's a common approach in standard mechanical design, and we see this often in passive house, and I like to bring this point up because it's a point where projects can they can improve the efficiency or optimize the design a bit better. So typically what you see is you have an HRV, and a lot of passive houses are going with heat pump based systems. So in this case, we have a VRF system, so refrigerant based systems, and it's ducted. So we've got our indoor unit here, and the outdoor units are on the roof. And then what we do is duct the heated and cooled air into the space. There's actually 2 or 3 fan coil units per floor, and we basically circulate air into the space, heated or cooled, and then we return the air back to the unit and reheat it, recool it, and put it back in. What's commonly done is is for the ventilation supply air to be ducted into the fan coil unit, either directly into the return air or sometimes into the space where the return air is taken from. So if you have like a mechanical room, the return air might just be taking air from the mechanical space, so that the supply air might be dumped in here. Now this seems all fine in principle, because you're then using the heat pump to distribute the air, so you don't have an extra set of ducts. The problem with this though is that we actually end up running an additional fan to circulate the air, right? So normally the HRV, it has a fan inside to push the supply air to the spaces as needed. With this setup, we end up having to run this heat pump fan to drive the air. So in heating and cooling mode, that's not a problem. We're already going to be running this fan to heat the building. But when there's no call for heating or cooling, right? The inside room is at temperature. Well, we've got the supply air coming here. We still need to run this fan to drive the ventilation air. And this ends up costing extra energy. And depending on the design, it can vary quite a bit. In this case, our overall energy budget, it was about 2% of the budget. So not huge. We've certainly seen much higher on bigger projects. So we've seen, for instance, on student dorms, this can get up to like 5% of your budget. Which again seems small, but when you start, it's all these small things that add up to noticeably more energy demand in conventional buildings. So I think that's a point that this and other projects we've seen can definitely optimize. In terms of the kitchen ventilation, this was the biggest challenge. Oh, sorry, that's misspelling. It's the restaurateur. So the owner of that Italian restaurant that was there for many years, and will be populating the building again. They were insistent on having a gas stove. So we had some discussions about switching to electric based system, and based on his style of cooking, he didn't want to make that switch. So we did have to have the gas stove, which has a consequence on how much exhaust ventilation you need for the kitchen. You just get a lot more pollution or pollutants from that. And if we compare the load of the kitchen exhaust ventilation to the background ventilation required for the occupants, it's actually quite a bit higher. You can see what would be required based on the occupancy is around here. This is in CFM, so just over, I think it's about 600 CFM or so. The kitchen exhaust by itself is over 4 times that. So it puts a huge extra load on the building. Now, the commercial kitchens we've worked with in the past, they've always been in much bigger buildings, so they still have an impact overall. But relative to the size of the building, it's noticeably less. So because this is only a 3-story building, this restaurant is quite impactful. Okay, so in order to reduce the energy required to supply this exhaust, this amount of exhaust, first off, we introduced demand control ventilation. So this is essentially where you're varying the rate of the exhaust based on the actual, well, there's a couple of different methods. You can use it based on time, or you can use it, control it based on heat and or smoke, pollutants like that. And so this actually hasn't been fully designed, the kitchen. That's going to be in the future. But what we our basis was to based on detection of heat and smoke, and we just essentially estimated with a kitchen consultant what the rate would likely be throughout the day. And so for about 9 hours per day, we'd be running at the full, it's about 2,800 CFM. 5 hours we could reduce down by 25%, and then the other 3 hours, so 17 hours total operation, the remaining 3 would be at 60%, right? So then the effective overall average rate is lower than 100%. So, you know, it's not massive savings relatively. Well, it's, you know, compared to the ventilation overall, it's actually a good amount of savings, right? Probably, you know, what's the average of like 80%, maybe something like that. So this is definitely an effective strategy, both in terms of energy savings as well as cost effectiveness. Our second strategy was to use displacement ventilation. So normally with a kitchen, what you do is you have exhaust air, and then you need to make up that air, right? Especially because we're in a airtight envelope. But even without the airtight envelope, because of the volume of air, you would need to have dedicated makeup air. That's essentially fresh air that helps offset the exhaust air. And so normally you would do that directly into the kitchen, and you would provide ventilation air to the seating area. And this would have been done with a regular ERV, right? Just like we have with the offices, right? We have occupied space. We bring in fresh air through the ERV, recover and exhaust the stale air, and recover the heat between the two air streams, right? So we preheat this air quite a bit, right? But these would be treated independently. So for this project, what we did was said, okay, well, instead of having this extra ERV where we put fresh air in separately into this restaurant space, what we're going to do is not send the makeup air directly to the kitchen, but actually send it into the seating area here, right? So we don't actually put it through an ERV anymore. We put it through the makeup air unit, which was going to be serving the kitchen directly. Instead, we're going to direct that air first through the restaurant area, and then that passes through into the kitchen and then gets exhausted, right? So we still have, you know, this amount of air going through, right? We have to exhaust this air, so we have to match it with the same amount of air, but we avoid the extra ERV in doing so. Okay, and so that meant basically we didn't need an ERV to serve this area. We just needed an ERV to serve the, let's say, back of house area, or well, not really back house because we have some washrooms here, but just some ancillary rooms here. Okay, then a third option that we explored was actually using an earth tube underneath the building to preheat that kitchen makeup air. So if we're having to bring in this makeup air, we're having to heat that from outdoor air temperature up to room temperature, or well, at least room temperature. Well, instead of having to heat it from outdoor air, why not bring it through an earth tube to preheat up to potentially up to the ground temperature. So we actually, you know, designed out a system here that would take in the fresh air, go through the tube, and all the way back into the building, right? Like that. Okay, and then what we realized in doing some detailed analysis of this is that we don't want the air to go into the ground or into the tube in the ground all the year round. We actually need to regulate the temperature of this because what you can actually do is end up cooling down air when you don't want to. And I've got a little graph that shows this. So what we did was actually add we would design in a damper which controls where the air flows, whether it goes into the earth tube and then into the building, or it would go directly into the building. Okay, and just to demonstrate, how this works, this temperature change. So we've got the different months of the year. We've got the outdoor temperature, swinging. This is the average monthly temperature. So in January, it's 4 degrees. In midsummer, it's looks like 18 degrees around there, right? So it's fluctuating throughout the year. Then we have the ground temperature, which also fluctuates throughout the year. And this is the monthly ground temperature, right? And what happens is in the cold periods, our outdoor air temperature is colder than our ground temperature. So we actually want to bring the air through this tube because the ground can actually heat up that outdoor air, right? Whereas once we start getting into a warmer period, what's going to happen is the outdoor air temperature is warmer, but if we bring it through the tube, the ground is actually going to cool that air down, and we're going to have to reheat it to a higher, we're gonna have to add more heat to it to get it to this adequate temperature. So there's this zone during the year where we don't actually want to run it through the earth tube. And so this took us a bunch of thinking to figure out how to do this. We ended up having to modify the passive house software, the PHPP, in order to actually properly model this. So that took some good thinking and work, but we managed to do that and estimate how much impact this would have. Okay, but unfortunately, it is a bit more of an elaborate system than on a, your typical small, 3-story building, and so it did get valued engineered out of the project. Okay, for a bit of insight into the energy balance, just what I wanted to actually speak about the south orientation, because it's actually, this is an ideally located site from a solar access perspective, so we could get a good amount of solar gain, right? And we can see this here. We've got, if we look at the heat supplied to the building, a lot of it comes from solar gain, right? And we actually have not that much loss. So the gains are much greater than the loss because almost all of the glazing is south facing. But the problem is that when you have such an abundance of solar gain, and this building's not overglazed, right? You've seen the renderings. Just when you have all that solar gain, and there is a good amount of occupancy, like with the restaurant, the patrons coming, or the office staff, that you end up not being able to use a lot of those solar gains, right? So you've got a lot of solar gain available, but there's good periods of the year where you've got to room temperature, right? You're at your 20, 21 degrees, whatever's comfortable. And then the sun starts shining and you're pumping more solar gain into the building, and you don't need it to be higher than 21, 22, but the temperature is just going to keep rising because of that extra solar gain. So that's what is meant by not useful. It's not offsetting your heating demand in those cases. So I thought I'd point that out. That's definitely something to be aware of in designing when you're looking at solar gain. Okay, in terms of controlling solar gain in the summer in particular, the restaurant level, there is a nice overhang. And then offices, there are no fixed shading elements, and operable external blinds, I think, weren't an option for cost reasons. So there are a few operable windows for natural ventilation. Just to note, this energy balance, for those wondering, this is without the kitchen ventilation. This actually gets a bit skewed with the kitchen ventilation. And then on the heating and cooling system, I already mentioned, we've got a ducted VRF system. And then hot water, the biggest load there was the kitchen, because you've got quite a few patrons per day. It's a good amount of water demand relative to the size of the building. We did explore the sand and CO2 heat pump, but that doesn't have enough recovery, which basically means in order to meet the ongoing demand of the kitchen, the heat pump can't recover and produce enough heat in enough time. So it can produce the heat very efficiently, but if you have big continuous draw or frequent draws, heavy draws, the heat pump just doesn't have that the power, the fast acting heat generation that a standard gas boiler does. And so it just wasn't, from a performance perspective, wasn't adequate. So there's a natural gas tank there, and then the offices have just really small local electric resistant tanks, so one per floor. And that's it for Passive House.
I think, yeah, let's see if we had a few questions off the bat there for Andrew. I know, Scott, you, of course, have a couple. Why don't you unmute and ask them yourself?
Well, Andrew, this is an intriguing project. And the one thing I was wondering about, when you bring that air, the makeup air, how are you heating it? Like, you can preheat it, but then how are you putting the extra heat to it?
That's a standard makeup air unit, which now is located on the roof because, I mean, originally we're going to do it in the ground floor to connect it properly with the earth tube, right? But because that earth tube's no longer there, the makeup air is coming basically from above and being heated with a makeup air unit on the roof.
So it's a gas-fired makeup air as well?
Yeah.
Oh, too bad.
Yeah. And I'd love to have seen the earth tube in action.
Well, yeah, but even the earth tube, I didn't think would get it warm enough. So.
Yeah, no, it was designed to get it basically to maximum output, which is, it gets it to ground temperature, which is, pretty good. It's like, or we could, let me see, I could just bring up the, well, you're not going to see the graph, but it is, ground temperature is between, it drops to about 10 degrees up to about 15 degrees maybe. So it can, it definitely does have an impact. It's just the kind of cost to energy savings is harder to justify, right?
Right. And then on your sand and heat pumps, I mean, if you put enough storage in, they would work, right? Is it just a volume problem? You just didn't have anywhere to put the tanks?
Yeah, I mean, that was, we probably have to get, I mean, it's been a while since we worked on this, so we'd probably have to get mechanical engineer in, Willie Perez to speak a bit more about it. I don't remember the detailed discussions we had now about why we couldn't get the sand into work.
And my last question was, I was wondering why you had to vent the elevator shaft. We haven't been doing that in any of our buildings, as long as we're in the hydraulic elevator.
That's a question. That's a question for Willie as well.
Okay, all right, fair enough.
We can call him up now. Yeah.
I'll talk about that for a second too, because it's driving me crazy. So we've been through this a couple of times, and then there seems to be, both with the city of Vancouver and the city of North Van, different points of view. So it's electric drive. So we're not dealing with the hydraulic. For the one we're doing in the city of Vancouver, they've come back and said that they need to be able to expel the extra heat that's building up from the use of the elevator, which is going to be literally like, I don't know, like the amount of trips that they're saying the elevator is going to take in a small building like this is out to lunch. So we're getting all this weird feedback from the city as far as what their expectation is to vent it. So we're pushing back pretty hard to not do it because we don't think it makes any sense at all. But I can tell you the project architect on the Ontario project is literally like going to throw somebody out the window of the city of Vancouver, because you keep getting these kind of people coming back with these kind of old ways of thinking about things, and they won't let go, right? They're like, well, you have to vent it. Well, it's not hydraulic. I don't have to vent it. And they're like, well, now you have to vent it because of the heat buildup. And you're like, what in the world are you talking about? So, I don't know. There's a couple of things like I would have loved to see. I mean, we did all the energy modeling for the earth tube. I think it's a really good idea. It just needs a bigger project, right? Like that I think is the reality. But the elevator stuff drives me nuts because it's.
The only reason I say that is we do not have any vents at the top of the heights, which is 6 stories of elevators, twin elevators in the shaft. No problems. We got one in the city of Vancouver under construction right now. No vents at the top of the shaft. We got one that it came up on the other day, and I just said, what do we need to do that for? Because it's not a hydraulic elevator, and everybody backed off. So it was kind of, it's one of those weird ones, right? I feel for you because I know how hard these things are. The heights, we did a really weird thing. We actually did balanced ventilation in the corridors, and we pressurized the corridors with the HRV, and we exhausted the top of the elevator shaft with the HRV. And our argument was, well, you know, basically we used the elevator shaft as a return air plenum in some ways, but nobody seemed to care. It worked fine. And we just put them on shut. They shut down on the event of a fire or smoke anyways. Yeah. Anyways.
There's lots of challenges here that aren't going to make the front pages of doing these buildings, but it can make you crazy.
Yeah, agreed. Thanks.
I think pretty good on time. And so now we'll move on to Joe, who is the construction manager and general contractor for the project. So you can take it away, Joe.
Great. Hello, everybody. Thanks, John and Andrew. Let me, I've got a ton of photos and some videos. So one of the interesting parts of the pandemic for us was we had a expert video editor from England apply for a laborer's position at Nykoon, and so he ended up doing a lot of video editing for us too. So I've got some good videos that I'll show you, and just trying to walk you through the construction sequence. Let me see if I can pull this off. All right. So that should work. No, sorry. That should go to slideshow. There you go. So yeah, transition some of those drawings from paper to reality. Just a bit about Nykoon. So we're known well in the single family world. About half our business is not single family. So we've been involved in high performance projects since I took Nykoon over 11 years ago. We were running our first sort of PHPP spreadsheets back in 2012, and we've got a half a dozen Pass-Fail certified projects either complete or in play now, this one included. And then myself, yeah. So my background's carpentry. Initially, I started as a laborer in this business and worked my way through there, and been 20 years now in this beautiful world of construction, and enjoy every day, especially projects like this. So super excited to be involved in this project, and it's been quite fun. It's been at least 2 years ago, I think, when it came into the office, and there was some starts and stops there just based on some challenges with municipality and city and these type of things, which we all face out there. But overall, logistically, the project's got so many tricks or challenges to it that it's not a big building, and maybe doesn't look that complex from the outside, but from a construction perspective, there's a number of logistical challenges. One, just the site itself being a zero lot line site on the corner of Lonsdale and Carey Cates Court, which is a major sort of thoroughfare of traffic and people. I think a lot of the site work happened during the early days and through the pandemic. So I think that was certainly a favor to us, where there was a lot less traffic on the road, and it made things a little bit easier. But that's the site there, as you saw before. And just some early shots of the boulevard. So we were able to get an agreement with the city to be able to take over a chunk of this boulevard to give us some working room, about the same width of the site, but it's only 25 feet wide and zero lot line. So really no area for staging, no area for parking, and just it's posing as the project's still going on. Just some logistical challenges that had to be well thought through. Just some shots of the demolition here, just give you some context. So that's really the site that we're working with once the building came down. We got pretty lucky in the sense that the neighboring building had a reasonable foundation, which was one of the major risks that we identified early before we tore that down. And so that was good. And there was also a retaining wall over on the property line that ended up helping us as we went through the excavation process. One of the requirements that we identified earlier was we're going to need some staging area. This was quite a bit of material and prefabrication work. Certainly was not going to happen on the site, and sort of just in time delivery of goods coming right out of the factories. Structurland provided the building, as well as BC Passive House provided the exterior panel components. Just wasn't going to work. It's just going to be too risky, very limited site space, traffic closures, and we just wanted to avoid any on-site hiccup risks in the assembly. So we were fortunate to find a space about a 5-minute drive away from the site. We had 2 acres there, which we were able to receive and land all of the goods weeks prior to installation. And so that was allowing us to really get an understanding if everything was going to fit together. So that was great. You can see kind of in the center there, there's a number of C cans that were bolted together. And so we were able to really create a pop-up prefab shop, essentially, where we had a covered shop in there. And then we laid out a large area of cribbing to give us a level platform to be able to lay that complicated north wall out. And not a bad view in both directions with the mountains and the downtown there. So that was pretty sweet for the gang out there. Just trying to, I guess, capture some magnitude of the amount of material. When it all arrived into the yard, it was kind of unbelievable to really look at all of that and understand how that was going to fit on that little 25-foot site, but it's all there now. Just jumping back, I guess, to the site a little bit, just trying to put some context into the number of things that were going on in parallel, where we were, excavating the site and working through the foundation, as well as prefabricating all the components and getting them ready for installation down at the yard. So there was a few delays with the city permit in the beginning, and so we had to get innovative on getting things moving and breaking sequence in some senses. I'll show you shortly, but running some stuff in parallel, which was all very successful. This is just a shot. We had to dig down about 6 feet of sort of loose silty ground, and then build it back up with compacted road base. And so just a few shots of the site there. Under slab insulation. So we took this stuff all to the prefab yard. We laid the footprint of the building out in the yard and took the entire loads of the EPS foam and prefabricated all of the components. You can see here starting to shape up some of the slab thickenings and other things that made up the under slab insulation and allowed for the structure to form right into that. So you can see all the pieces have labels on those. So we were able to use a digital process to sort of map that out, and then had a hot wire and cutting station on site, and basically got the entire insulation package prefabbed and ready to go in as soon as we were able to get to the site. We prefabbed all the stairs for the project as well during that time. So there's three flights of stairs on each side. And so those were all done, again, using a digital model to be able to make sure we were going to get all these components right. We bolted this model into the master 3D model in CAD work, which had Structurland components, all the steel, all the BC Passive House components, and then our structural components. So that was very effective. And everything did fit quite nicely. The other thing we did, which was not part of the original plan, but there's an elevator pit. It's really the only subterranean chunk of the foundation that goes down about 5 feet. And so we opted to, again, just trying to save some schedule time to precast this in our yard. And so that worked out quite well. We precast that. We got the approvals of structural engineer, and then we were able to come and just drop that in. And so that really saved kind of a 5 to 6 day sequencing on site of sort of forming bar, pouring, stripping, and waterproofing on site like you would typically. And we were able to just drop that in an afternoon and continue on with the build. Saved us a bit of shotcrete and other things on the side. So that was quite a win from a sort of outside of the box thinking there from the construction guys. So that was the elevator pit there getting dropped into play. So we were able to backfill that right away and begin with the foam. And so some shots here of the under slab insulation, number of penetrations, as you can see here through that. And so a little bit of time just drilling those holes out, and then we're having to spray foam all of these pipes in prior to our air barrier. But you can see sort of the the shape of the slab thickenings, and it's all built right into the foam. So limited formwork on the insides, just the slab edges that were done. And then we were able to form a curb right in and pour everything monolithically. So the air barrier, this is a Stego 15 mil air and vapor barrier here taped. And so everything fully taped, sealed to the pipes, and wrapped up the sides and the perimeters to tie into the air barrier on the number of different conditions on the perimeter. So one of our biggest concerns with this building was air tightness. You know, from what we know, building tight structures is that, you know, an interrupted or non-continuous air barrier is going to be your enemy. And so I think, you know, this air barrier's continuity breaks for probably 30 times throughout the course of this building. And so it's one of the biggest challenges that we had discussed and come up with strategies for early. So that was a really key to just be able to use our model and come up with air barrier strategies that we're comfortable with. So we're not at a point where we can test the building yet, but we feel quite confident that we'll be able to achieve the air tightness, air change requirements. Knock on wood. Yeah, just some shots of the poly coming up the forms and spray foam. And then, of course, all of our in-slab services coming into play. Rebar, of course, you know, having to have trade meetings early with all of the trades and making sure they're not dragging rebar and cutting through our air barrier here and understanding what we're trying to do here. So that was all very good. And then we poured the concrete. So about a 9-week process from the beginning of excavation to the completion of the foundation. And so it went quite quick. And then I'm just going to see if I can play you a little 30-second video here. Let me try this. Let's see here. So I'll recap that. There we go. There. So there's sort of that whole process up to that point in 30 seconds here. We got a video camera on the Polygon gallery across the street, so we've got a lot of time-lapse stuff. So yeah, digging the hole, building this back up, and then we'll see the services go in. And the underslab insulation that went in a couple of days. Air barrier bar and pour in the foundation. So that was 9 weeks and 30 seconds there. Okay, let me get back into this. I'm gonna jump around a little bit like that because I got a few videos. So anyways, there's the logistics stuff. Now, oops. All right. I want this. I knew this was going to be fun trying to jump back and forth on this here. So, what am I doing wrong here? There, we're back. Oh, great. Yeah, wonderful. So, where were we? Sorry, team. This is there. Okay, so we'll talk a little bit about virtual construction process. So we modeled the whole building from the construction end of things, and that proved to be quite beneficial. We're doing that with all of our projects here for the last couple of years. And so we were able to get together as a group, including the crane guy, the construction team, and other sort of key stakeholders in this. And from the beginning, you know, one of the challenges, you know, John was talking about too, is just sort of that north wall. It's a 34-foot tall wall. And the original sequencing we had come up with was that wall was going to go in first, and then we were going to build the structure inside of that. And through this process, which we went through 3 times, virtually constructing the building piece by piece, We ended up coming up with a different sequencing, so it was very effective. It was a big win. We had originally projected 21-day assembly at the outset, and then we brought down to 13 after the first meeting, down to 11 at the end of the third, and then it was actually executed in 9. And I can just show you that sequence as well here in a short video. And so, yeah, here it is. So this is a model that we had built out in collaboration with Structurlam and BC Passive House. We had everything in there from screws, all the hardware, all the steel components. There's actually quite a bit of pretty tricky steel connectors and details in this building. I'll show you some photos of those after this. But we were able to use this for a lot of our logistics planning, the crane swing and crane sizing, the sequencing of the actual panels, the assembly, and sort of just-in-time delivery schedule of the structure. And so it was instrumental in the success of putting this building up in such a quick time, and with really limited issues. There were some very, very minor issues on site during the installation, but largely inconsequential, and we gained days instead of losing. And that's the objective, where the crane and the 8-man crew and sort of the daily burn on site of having that crane there is what we're trying to save, and it was largely successful in that regard. So it was a good process. Geez, that's gonna do that to me every time, is it? I wish I was good as you on these, Chris, but I'm just practicing. So we got through there, and sort of that, yeah, we were able to hyperimpose that model into the site and use that for planning and other things, traffic control, traffic management, and so it's very, very successful. So we'll just go through some of the details of the construction. So mentioned, yeah, Structurlam supplied the structure of the building, a number of components. We received these about 3 weeks prior to installation, so we were able to lay out all the components in the yard, inventory them, and ensure that everything was going to fit. So we were able to dry fit all the components prior to them being required on site. And we did have a number of issues that were resolved. And so it was certainly worth the efforts. This is a shot. This is just kind of give you an understanding. Some of these connectors were quite complicated. So you can imagine, the number of members that touch a connector like that, and the tolerances that can be in there. And so we certainly felt more comfortable and dry fitting all of these in a yard. Just some more shots of the different structural components that connect this building together. And you can see just the detail and the number of cuts, holes, dados, and everything just in one post base. And so we certainly had our work cut out for us to make all of these assemblies go well. Whatever we could bolt together in the yard, we did, and bring that to site partially assembled. And so that again added to a lot of the speed in which the building was erected. So we had our same crew really inventorying and understanding each component. So these guys, there was 8 guys from our side that assembled the building and did all the prefab, and by the time that building was going in, they knew every piece and every part, and so it was a great process and well worth the time. So yeah, just now getting to the actual sequencing. So I'll run through some photos, and then I've got some videos I'll play that kind of show the building going together. So it's really the first day of the assembly was just all of the columns being stood. That was just done by hand. The second day, the crane was mobilized and began putting in the main floor beams. So some shots there. We had a truck running between the laydown yard and the site, a flat deck truck, which was bringing the components that we needed just in time for the crane to install them, and so that worked out quite well, being so close. That was a brace frame that was installed on the ground and then lifted into place. Just a bunch more just detail shots. So that was around lunch of the second day of assembly. And then we started flying the CLT panels, which were 5-ply panels for the floor. Sort of the beginnings of day 3. Now you can see the frame starting to go up. All the stairs went in sequence with the building as well, so we were able to have safe access up and down as the install was going together. This is the end of day 3. And then try this again and play you a time lapse of that. Okay. So there is, yeah, here is 30 seconds of this. So that's sort of the first day. The columns are up and crane mobilizes. So this is conclusion of day 1. All the guardrails are all prefabricated as well. And this is the conclusion of day 2. Columns go up on that level. And then the next step is to install the infamous north wall. So you can see that that's not in it yet. And so we slipped this wall in between the 2 buildings. And I'll just run through the sort of sequence of that as well for you. So, yeah. All right. So, yeah, here we are. So the north wall. So I'll just run through this. Geez. Sorry, folks. That's somehow my unlucky day here on these.
Because you're using a Mac.
Yeah, is that what you think it is?
No.
Yeah, I'm just blame myself, I think here.
What if you, Joe? What if you were to double click on the photo, like in that scroll menu on the left next time? Like if you double click on it, does it just start from there?
I'll try that one. Yeah. There we go. I made it again. That'd be painful if we have to do it again, eh, Roberto? But here we are. So yeah, I'll just run through this. It's quite interesting sequence of the offsite construction. So this is the yard that we mentioned. So we laid a bunch of cribbing down to be able to essentially lay that north wall out in sequence and be able to prefabricate it. So you can see the panels coming in here. We built a little hut that was able to be lifted on each individual panel just to cover for weather. So it's just larger than the width of these panels. These are about 34 feet tall and I think about 7 feet wide. And so you can see them all laid out in sequence there, and that's sort of how the hut worked. So they just worked through kind of one panel at a time and just worked their way down. Significant amount of detailing on the edges for air tightness. So this is a Siga tape which was wrapping out and into the inside of the building because the panel is exposed on the inside, and we've got no way of getting to the outside to be able to secure a continual air barrier. And so there's quite a nifty detail that the design team came up with, which enabled us to bring the tapes in and be able to tape the panel and the continuity of the air barrier on the interior of the building. And so that was quite tricky. This was the guys being innovative on saving their backs. And so you have a couple of carpenters rolling around on their tummy here, installing tape on all these panels. This is the inside is face down. Then there's a Suprema VP100 that went on the panels with a primer. They were using a 20-pound floor roller to sort of roll those on. So it was quite quick, quite effective, and huge win as far as you can imagine the difference between doing this on the ground or vertically in place off of genie booms and other things. So it's very successful and equitable. Some more shots there. These are the Cascadia fiberglass clips and mineral wool insulation that went onto this wall. And so those were all applied again, super fast. You can see here, even through wall flashings, this is sort of the break where the where the panel meets the adjacent building. And so we were able to put all the brake flashings and everything in place on the ground as well. So quite a bit of work and detailing went into these, but it all went very, very quick. Some more shots here of that process. We were lucky with weather. It did get wet for several days, but the tent worked. There's kind of a shot of that protected. And some of the panels being loaded up to head over to the site to be lifted in place. That's kind of the completion of the prefabrication of that north wall, and you can see all the components in the yard here being staged to be picked for installation. This is just a metal panel that was installed as a protection layer behind the adjacent to the building there, so you wouldn't see this, but if that building ever came down, this installation would remain protected. And that's sort of the first lift that we put the panels flying into place here. And so I got a video I'll show you here, but that's the installation of that north wall. And it was certainly not easy, very tricky. And I'll show you this video. We had about an inch of play between the adjacent building and the north wall, or the structure that we had just built. So it was a bit of a nail biter for sure, but ultimately it ended up getting done in one day, and we were expected it to be two, so it went very, very smooth. So I'll just play that. You can see that panel sort of being slipped down between the structures. This is the low side of the adjacent structure. Some areas are sort of less than an inch to be able to slip these in, but everything went quite smooth. We had beads of sealant between the base of the panel and the angle iron on the bottom, as well as panel to panel connections, just for an additional kind of help with the air tightness. And then continued on with sequencing the top floor here, just some shots of the building as it went up. That was kind of, yeah, that's where the model helped us out quite a bit. And that was that there. So let's try Roberto's trick here of double clicking this thing. Seeing if that'll let me share this screen. Okay. What do you think it's gonna work, Roberto? Let's see.
Oh,
no, man. What an embarrassment.
I'm going to say no.
I think in the menu, there's a start from the current slide that would have helped.
I'll get that one figured out for the next one, guys, I promise. You get to see this stuff again. I'm almost done here. I'll just go through the final bit of construction there. We don't get into anything, just the structure. So yeah. Okay, so yeah, that was the north wall, and then yeah, the rest of the wall, so the south, the east, and the west were built up in the factory in Pemberton, BC Passive House factory. Some shots of these walls being constructed, and so they're fully insulated, wrapped using Tyvek, and sent down on 2 loads, and they were installed over the course of 2 days. That's sort of the conclusion of day one. You can see all the angle iron that's on the bolted to the CLT floor plate. So those are both pre-bolted down onto the plates, and then the panels are just fashioned with GRK screws from the back there. So worked quite well. Went together very, very good. Just a shot on the inside here, sort of showing this brace bay and the panel installed, and those panels were taped on the inside, and so we'll utilize those as a secondary or backup air barrier. I think we'll be okay. and some more shots of those going in. And I got one final video I'll play. It's about 3 minutes long, which just sort of recaps the whole process, and then I'm done. Let me find that. There you go. Okay, I'll play this one, and that'll be the end of my stuff here. Hopefully that works. There you go. There you go. That was 9 days at about 3 minutes. So that's all I've got.
As someone that builds, that's pretty impressive, man. There's some serious problems that you guys worked through. So that was awesome. Thank you. All right. I got a couple of questions. Sean, you're up.
Joe, was that 9 days straight that you guys plugged through? Did you guys take a weekend off?
Yeah, so all the credit to my guys, Brent and Lucas and Ryan there, who led that. They took Sunday off, but otherwise ran right through. They tried to get a work. We did try and get a permit from the city for the Sunday, but it was declined. But overall, it was nine straight days, full structure and building envelope in off of the slab. So it was super awesome to watch that go together. That was 6 months of pretty intensive planning and logistics and sequencing and virtual construction, and it certainly paid off. There was really no major hiccups. There, of course, a couple hiccups during the assembly, but it was a huge success. Yeah.
And did you have a contingency plan in case the weather was bad?
Yeah, no, that's a great question. So we got quite lucky with the rain right up to the point the roof was on, and then we had a torrential storm literally the day before. If it had been 1 day later, we would have been completely dry the whole time. But we did get a reasonable amount of water staining in certain areas. We've got some different assets that can pull that out, as well as contingency in the budget at that time to be able to sand and restain the whole building if we had to from the exposed side, but we're not going to need to utilize all of that too. So there was a tarping and water management plan that we had, but it's going to be challenging in any project, I think. Fortunately, there's no we're not chasing it with drywall or fire rating or something like that up like in a taller structure. So it's just going to be more aesthetic.
Thank you for that. Eric has another question, but I know that your client's on the line, so you can plead the fifth and not answer. But Eric Lee, please ask your question.
I was just curious if you can share your construction cost estimate, even if it's just a rough ballpark, because we're not done yet, right?
Yeah, I think right now we'll just keep that. I think at the conclusion we'll certainly be able to share some numbers. I should chat with our clients and others just to make sure what's okay to be public and what's not. So I will have to just plead the fifth on that one for today.
Joe. Don't kiss and tell.
Roberto, you still there, buddy? I think he had to disappear. If he's not there, yeah, you are. You're muted.
Now I'm not muted. Yeah, so you and I talked about this, Joe, at some other point, I think a few months ago, but I'm curious about convergence here of modeling, because John's talking about, BIM modeling or BIM of like his design teams, they're looking at coordination models, overlaying mechanical, electrical with architectural. And then you talk about your coordination models with BC Passive House. Were you able to use their models for yours, or did you have to start from scratch?
So the different models. So in our case, the sequence was we unfortunately there's a lot of redundancies in modeling today. I think between an architectural model, a structural model, and our construction model, they're all built for different reasons, and so therefore they may not have the same underlying data in them that we would want as a contractor where we're doing our estimating. So in this case, we built a model in Revit, a construction model right down to the rebar. We then exported that to StructureLam in an IFC format, and they imported that into CAD work. And so this is going to be an end actual production model that saved them about 70 to 80% of their time. So that was successful. They then sent that CAD work file to BC Passive House, who built their panels modeled in that CAD work model. It then came back to us. We put our stairs and other components that we were building ourselves into that model, and then we imported it back into our Revit, and we used that to be able to sequence the construction, that and another software called Navisworks, which allowed us to be able to move the parts around. And so we're fortunate to have some technicians in here that are project managers that understand the software and are able to use that. So I think over time, we're hoping to see, it can be done now, everyone working in one model, but we've never seen it successful. And so for our purposes of construction modeling, we're generally just building them from scratch, because it's the actual process of building that model in the same manner that you're going to construct the building that's actually the value. It's not necessarily the model at the end, which has a bunch of different values to it, but for us, it's just more of, how is this going to go together, and how is this sequence going to work? And so that process of doing that virtually versus just starting with that in the field is where the value lies from our perspective. And
I think there's a clean break from most of the coordination models that we're coming up with, because our stuff is still all, sounds ridiculous, but we still are building all physical models first, which we didn't show today, but all of our design methodology is coming from physical models, which are then being translated into digital different like we're either Rhino or SketchUp or Revit. Like there's kind of different ways, but because we're moving so many different things around, trying to find solutions, that model, and then that model usually is rebuilt for us at the end of design development, and then again at the end of like IFC or like just post tender, so we can kind of get all that stuff in. But that's more for kind of coordination for us. I mean, I don't think that a contractor would take our model anyway and build off of it, because like I said, Joe's, it's more about sequencing and everything else. So maybe there's a future world where it all comes together, but I can say personally, from our perspective, is that, you know, this is the most rectilinear building that we've done. Usually there's more to it than that, and yet it's all coming from physical models. Like we started like 1 to 200 up to 1 to 100, end up 1 to 50 models, and that's what we're pulling through as our design methodology. I don't see us personally ever getting to a place where we're designing buildings in CAD. Like it's my own bias, but I think that the translation for coordination really works. Like I did a restaurant at Kitts Beach like a long time ago, before I was like and we were building 3D models of that stuff, just coordinating the steel and the glazing and all that. So I think that those are from a design perspective make sense, but once it kind of goes over the fence, you can use some of the geometry, but it's the same as shop drawings. Like, you know, people are taking our model for shop drawings, our drawings for shop drawings. They're still kind of, you know, they still have to make sure it works for them. So I don't know, maybe there's a grand unification in I'm sure there's lots of people selling software to do it, but I'm a little dubious personally.
Yeah, agreed.
That I want to, well, John wants to know if you wrote the music, Joe.
No, the music I write's a little bit harder than that. Like Roberto likes my music. It's got a lot more bass to it.
I'm Eamon, your question? You there still? On mute.
Hi, yes. Yeah, just, you know, like I think the project looks really amazing and very impressive. So is there any potential for like any residential project? You know, passive house, prefab, similar process.
From our perspective, we're working on a large scale development outside of Toronto now that's kind of looking at these same technologies of CLT floors, the prefab walls, but we're going a step further. The project's going to be island ready, so it's recycling all its own water, generating all its own electricity, kind of going this way, and the mass timber is a kind of way of kind of approaching that in the prefab way, so we can do that. So I hope it works, because we're kind of investing a lot of time into that project, but I think that none of this stuff is rocket science now. It just takes people thinking things through and a combined effort where we're all working together. And it sounds cliche, but it really is true. Like if you've got kind of any sort of kind of lack of confidence between the design side and the construction side, it usually kind of erodes pretty quickly. So I think in this one, we've all kind of learned a lot, and we've had a long time to work on it too. This wasn't a fast development. Like when we started this, you know, it was still, people were still scratching their head about what you meant by passive house, and now we're building it. It seems like it's kind of almost, you know, an everyday thing. So
Thank you.
Do you want to add to that, Joe? I know you do a lot of residential construction.
Yeah, I mean, we've done a couple single family buildings with CLT and prefab stuff, and some smaller multi-family stuff. I think the larger residential condos, there's some things in development that I know of. I think the challenge starts coming into the floor plate. I think, I mean, the architects would probably be able to answer that a bit better, but being able to work optimized floor plate inside of a mass timber structure, I think the structure ends up starting to come first, and then I think the numbers are a little bit harder to work. But I think, yeah, definitely, I think it'll definitely get there. And there's a few things on our desk that are potentially going to go that way. So
I think the only thing I'd add to it in the residential and single family world is that the form factor of this building, being that rectangular, really lends itself for a cost-effective prefab CLT setup. And so if we start to accept that, or we build our houses that way, it's a lot easier. And it rolls back to a lot of the conversations that are being had in these pass house circles on your form factor and shape. So simplifying that shape, but still getting a high quality of design, which I think was successful in this building. The renderings are awesome. And still having a really strong street presence is really critical. So I think that's what has to come out of it, so that we're not just building really simple. Like, you have to build a simple box, but it also has to look great. So Sean Saintamore.
Joe, is your team ready now for another Brock Commons? Now that you've been able to do 3 floors, are you ready to go for 18?
Absolutely. Yeah, we're ready.
And is the glass finally out of Montreal? Is it finally
we have a container in Halifax, I think, on a train now, and another container has been routed through Panama. And so, yeah, we're hoping to get this stuff next week. And we planned for the worst, and it was a bit disappointing because really the glass could have gone in right away. It has not affected the critical path of the project at all yet, but it's getting very, very close. Where obviously you see the renderings is a beautiful brick finish, and so we've been able to chat with the brick crew and give them the heads up on timing, so they should be able to double up on their crew and get their portion of the project done. Hopefully about 50% faster than the original plan, but it's definitely getting close. So yeah, that's the challenge with products coming overseas, as we know, is that we always joke it's the ship's going to flip over, the port's going to be on strike, and the stuff's going to show up broken. And in this case, we've had the port on strike and containers go missing, and I sure hope it doesn't show up broken. But yeah, well, so
it might show up in time for the building permit, Joe.
Yeah, exactly. That's another story right there, isn't it?
Again, that'll lead me to, I think that was the questions, and I'll ask it. We talked about it, some of the prelim stuff, but City of North Vancouver, I know that John, you mentioned Tim, but generally, maybe you can allude to what you meant by maybe the building permit will be ready. Or in general, how is it working with the municipality? I know that there's been a few Passive House projects that have come across and then not made it across the finish line. So just maybe talking about the City of North Vancouver.
I can say, from our end of it, I don't think the Passive House played much of a role in the kind of the timeline. Like, it did at the beginning when we were doing the modeling, like I do the energy modeling for the underground tube to make sure that it would work. And then Andrew spent a lot of time working with the Institute to try to figure out how we were going to manage this kitchen thing. But as far as the kind of approval process, what has kind of been difficult is just the everyday stuff of kind of getting it through engineering, right? Of kind of doing with that kind of stuff, which isn't have to do really anything with mass timber or Passive House, but we're seeing the same thing in a project in Vancouver too. There's just such a delay when it comes to kind of dealing with these kind of things that you would think would be kind of easy to deal. So even though this project is super challenging and it's got a crazy list of what we're doing, the reason we don't have a building permit yet has to do with the engineering department and the street design. Like, there's stuff here that should have been done years ago. It's just, and yes, it's a pandemic, so we're all taking a deep breath and going, it's fine. But a lot of this predates all of that stuff. So I think that what I will give full credit to Tim for was when we came to him saying, okay, this is our alternate solutions. He was very open to it and kind of understanding how it would go. And one of the big things for us is that we didn't want to cover up the CLT. You alluded to Brock Commons with a whole bunch of drywall. We wanted to expose it. We wanted to kind of show that it is a reasonable material to use. It's not just a one-off. You can do this and build a safe, and aesthetically pleasing building. So he was very open to that. And then we got into kind of some complications around how the code is written around the energy performance, which he was pretty open to. So we managed to solve those problems, I think, in a reasonable amount of time. But the kind of the lack of I don't want to be too controversial about it, but how the lack of kind of real desire for the bureaucracy to move any project through the process. It's hard to understand for clients. It's really confusing that you say it's going to take this amount of time, and they say why, and you say, well, I don't know, like it's just going to take a lot longer. So that's been our problem with this. It has nothing to do with passive or nothing to do with, I mean, the design panel was very, very supportive of the project when we laid it out for them, which we thought would kind of just open the door to get through everything else. But it seems every project that we do now, the other end of it is we just finished an ice hockey arena last year in Hazelton, all mass timber, prefab panels. The whole thing was built. And when I went to the building inspector there and said, look, I'm going to show up with these drawings and everything, you're going to have this huge package. How long is it going to take you to process the building permit? And he was like, thought for a while, really nice guy. And he said, well, if you gave it to me on a Monday, I could get it to you by the end of the day on Wednesday or Thursday at the latest. Right. And so that's, one end of the extreme. But when you're dealing with projects here, they're taking years to get through for permitting. Like even the On5 project that we're doing, the Twin, took over a year to get through the FSR calculations. Like, how does it even make sense? So that's my biggest problem. Isn't what we're trying to do here progressively. It's just the everyday stuff. It just takes ridiculously a long amount of time to get it done. So from my end of it, I do applaud for Tim because he's letting us build this. And to the point is we're working under a kind of a manager's approval here, but I don't have the building permit in hand. And the building went up in 9 days. I have to keep changing because I keep saying it was 8. So 9 days it went up, and we're still waiting for the issuance. So it's a complicated world out there.
It's testament to a good team getting it up and doing it. It's interesting on a Passive House social, we're leaving Andrew with no questions. It's good. That means we all know what Passive House is. It's other issues that we're tackling. I like it. I have no problem cutting these Zoom meetings off early because I think we have enough of them. But if there's any follow-up questions or anyone wants to say anything, here's your chance. If there's nothing else, this is recorded, so I will be firing it up there. Yes, that would be impressive. I like your comment. I'd like this thing to get certified before you get a permit.
It's going to make the occupancy permit a bit confusing when I don't even have a building permit to tie to, but we'll see what happens.
I really appreciate everybody coming out. There's lots more events coming up. Make sure you check out passhouscanada.com for everything that's coming up. I do want to thank John, Andrew, and Joe. This was a great presentation. I apologize we couldn't have done it in person. We'll keep trying to come up with innovative ways, but for now it seems to be Zoom, and days like today make it worth it. So thank you guys for that. Lots of really insightful information. And with that, see you guys. Thank you.
Thanks very much. Take care, everybody. Be safe.
Thanks for hosting. Thanks, everyone. Bye now.